Bolt action. It starts in Prussia in 1841 with a problem nobody had solved cleanly before. Johann Dries built a system where a metal needle drove through a paper cartridge to detonate the primer. It worked well enough to change warfare. It also snapped constantly and vented hot gas directly into the shooter's face on a regular basis. Progress, but not finished progress. Paul Mauser looked at that foundation in 1898 and rebuilt it into something that would outlast almost everything that came after it. The Gewehr 98 introduced two front-locking lugs, controlled feeding, and a gas shield that redirected pressure away from the shooter if a case let go. The design was so mechanically settled that virtually every major army that entered the First World War, and then the Second, carried a variation of it. The Springfield M1 Tyno 3, the Lee Enfield, the Arisaka. Different names, same ancestry. The cycle itself is 4 movements. Rotate the handle up to unlock. Pull back to extract and eject the spent case. Push forward to chamber a fresh round. Rotate down to lock. What that process produces is a chamber closure with zero mechanical interference from anything else in the system. Nothing is moving except what needs to move. That rigidity is why precision shooting at distance lives here. Any inconsistency in how a cartridge seats changes where the bullet goes at range. The bolt action eliminates that variable. Cartridges like the .308 Winchester and the .338 Lapua Magnum, which was developed in the 80s specifically for military snipers working past 1,500 meters, exist in this action because nothing else handles their pressures as cleanly. Chris Kyle rotated between 300 Win Mag and 338 Lapua based on how far the target was. That's one of the few technical details the film got right. Lever action. It may not be the most practical action ever designed, and it is certainly not the most modern. It is without question the most satisfying to operate, and it's what John Wayne used, which settles certain arguments by itself. The lever wraps around the trigger guard below the trigger. Pull it downward through its arc, and the bolt travels back, strips the spent casing out, and clears it. Return the lever, and a fresh cartridge climbs out of the tubular magazine, running under the barrel and into the chamber. One continuous motion. Faster cycling than a conventional bolt, and with a mechanical elegance that nothing else in the category touches. The Henry rifle in 1860 held 16 rounds of 44 rimfire, and a trained shooter could run it at nearly 28 rounds per minute. Union soldiers during the Civil War purchased them out of their own pay because the Army wasn't supplying them, and they understood what the firepower advantage meant. The Winchester 1873 took that foundation mainstream, and the lever action defined American civilian shooting for the following 50 years. The tubular magazine creates a genuine constraint, though. Cartridges stack with the nose of one round pressing against the primer of the round in front of it. A pointed bullet tip sitting against a live primer under recoil is an obvious problem. Lever actions run flat or round nose bullets for this reason, which is why 30-30 Winchester and 45-70 Government dominate the format. The 30-30 arrived with the Winchester 1894 and remains the cartridge most connected to deer hunting in the United States to this day. The .357 and .44 Magnum also run in lever guns, which is a detail worth knowing. One footnote that belongs here. The T-800 in Terminator 2 runs a Winchester 1887 in 10-gauge one-handed, spinning it through the air off a Harley. The lever loop was physically enlarged to make that move possible. Arnold grabbed the unmodified version by accident during filming and came very close to breaking 3 fingers. In Red Dead Redemption 2, every cocking animation on the Lancaster repeater mirrors the real mechanical sequence exactly. That arc you cycle hundreds of times in the game is not invented. Pump action. Ask any uncle over 60 what the correct answer to home defense is. The response will be immediate, confident, and accompanied by a sound effect. The pump. Because everyone is afraid of that noise. He's not wrong about the noise. John Moses Browning brought the first commercial pump to market as the Winchester Model 1893, then ran into a timing problem immediately. He'd engineered it around black powder, and smokeless powder arrived on the market shortly after. The receiver wasn't built for the pressure difference. Winchester's response was unusual for any era, a full voluntary exchange program. Every Model 1893 swapped for a new model at no charge to the owner. Most of the returned guns were destroyed, which is why original 1893s are genuinely scarce today. The Model 1897 that replaced it ran for 60 years and went through 2 world wars. American soldiers carried a trench variant in the First World War fitted with a bayonet lug and heat shield on the barrel. Germany filed a formal protest against its use in combat. That protest tells you most of what you need to know about what the weapon was doing. The mechanism puts complete control in the shooter's hands. The forend moves rearward along its rail. The bolt travels with it. The casing extracts and ejects. Drive it forward, and a fresh shell feeds into the chamber. No gas system, no recoil operation, no mechanical dependency on the ammunition performing within a specific pressure window. A misfired round clears with one stroke of the forend. A semi-automatic in the same situation is a more involved conversation. The format handles everything: home defense, bird hunting, deer, bear, clay targets, less lethal rounds, and yes, dragon's breath shells if the situation at your barbecue has truly gotten out of hand. The Remington 870 sits above 12 million units produced. The Mossberg 500 is close behind. Brake action. A lever on the side or top releases the lock, and the barrel pivots downward, opening the chambers completely. Rounds go in by hand. Close it and the gun is ready. After firing, the extractor lifts the spent cases out for removal. This is the oldest working shotgun configuration still in regular use. Double-barrel percussion shotguns of the 19th century operated on this exact principle, and the core mechanics haven't required updating since. Fewer components means fewer things that can fail, and the brake action offers something no other design can match. When the gun is open, its condition is completely unambiguous. The chambers are visible. Loaded or empty requires no interpretation. Over-under configurations with one barrel stacked above the other are the competitive shooting standard for skeet and trap. The consistency between two shots matters more than any capacity consideration at that level, which is why serious competitors spend serious money on Beretta and Perazzi over-unders. Side-by-side arrangements with parallel barrels carry a different association, more connected to British field hunting tradition. And yes, this is the shotgun from Doom 2. Revolver. The cylinder is the solution to a problem that stumped handgun designers for a long time. How do you give a pistol multiple shots without building a feeding mechanism complex enough to fail regularly? Arrange the chambers in a circle around a central axis and rotate them into alignment one at a time. Single action requires the shooter to manually cock the hammer before each shot. The trigger releases it only. Lighter pull, shorter travel, slower overall rate of fire. Double action does everything in one trigger pull, rotates the cylinder, cocks, and drops the hammer. Most modern revolvers handle both. The .38 Special was the standard American law enforcement cartridge for decades. The .357 Magnum appeared in 1935 with a case running slightly longer than the .38, so that cross-loading was physically impossible in one direction. A .357 cylinder runs both cartridges. That remains a practical consideration today. The .44 Magnum found its audience through the Smith & Wesson Model 29 in Dirty Harry. When that film released in 1971, Callahan's claim about the most powerful handgun in the world was technically accurate for that moment. The reload is the design's permanent liability. A modern pistol drops and reseats a 15-round magazine in under 2 seconds. The revolver requires individual case ejection and individual reloading, or a speed loader that adds bulk. Why does anyone still choose one? The answer is straightforward. It looks like a cowboy gun, and that has never stopped being relevant to a certain kind of person. Semi-automatic. This is where the majority of modern firearms live. The energy generated by firing the cartridge is captured and used to cycle the action automatically. The case extracts, a new round feeds from the magazine, the bolt closes. Pull the trigger again. 3 distinct methods exist for capturing that energy. Gas operation diverts a portion of propellant gas from the barrel to drive the bolt carrier rearward. The AR-15 uses direct impingement, meaning the gas enters the bolt carrier key directly. The AK-47 uses a piston sitting above the barrel, which takes more punishment in adverse conditions without complaint. Short recoil operates differently. The barrel and bolt travel rearward together briefly after the shot, then separate and the bolt cycles independently. The Glock, the Beretta 92, the Sig Sauer P320. Nearly every modern service pistol in 9mm and 45 ACP works this way. Blowback is the simplest of the three. Gas pressure pushes the spent case directly backward into the bolt, driving it rearward against spring tension. No locking mechanism involved. It works cleanly at lower pressures, which is why it lives in .22 LR rifles and pistol-caliber submachine guns like the MP5 and the Uzi. Full auto. The mechanical principle is identical to semi-automatic in every respect except one. The disconnector, the component that in a semi-automatic prevents the next shot until the trigger has been fully released and reset, is either removed or bypassed. Hold the trigger and the gun keeps cycling until the magazine is empty or you let go. A 30-round magazine in an M4 on full auto is gone in under 3 seconds. By that point, accumulated recoil has walked the muzzle well off the original point of aim. Full auto is not a precision instrument. It is a suppression tool. You put rounds in the general direction of a threat and force heads down while the rest of the team moves. Understanding that distinction explains most of the doctrine around when and how it actually gets used. Straight pull bolt action. A standard bolt action requires 4 separate hand movements to complete one cycle. Lift, pull back, push forward, close. The straight pull collapses that sequence into 2, pull and push. An internal cam or lug system handles the rotation automatically. The result is a bolt action that cycles considerably faster while keeping all the mechanical precision that makes the design valuable in the first place. The Blazer R93 and the Browning X-Bolt Speed are well-known examples, and the format has a strong following in European hunting circles, where a fast second shot on moving game is a real operational requirement. No military has adopted it at scale because the internal complexity costs more to manufacture and maintain. For the hunter who won't trade precision for speed and doesn't want to choose between them, it sits in a category of its own. Rolling block. Remington brought this design to the Paris Exposition in 1867 and left with purchase orders from Sweden, Norway, Denmark, and Egypt simultaneously. Within 2 years, it was the standard service rifle of multiple armies at once. The mechanism is built around a curved block that sits directly behind the chamber. Pull the hammer back and the block rotates down, opening the chamber for loading. Once the cartridge is seated, the hammer physically locks the block closed when the gun fires. Chamber pressure has nowhere to go except forward. Single shot with no magazine, but the mechanical strength it produces is exceptional. France was still placing orders for rolling block rifles during the First World War to arm rear-line troops because the supply of modern repeating rifles simply wasn't keeping up with demand. In Red Dead Redemption 2, the Springfield rifle runs this action, and the animation of thumbing the block open and loading each cartridge individually reflects exactly how the real mechanism works. Gatling a Rotary. Richard Gatling was a physician and agricultural equipment inventor who watched Civil War casualty trains arriving in 1861 and responded by building a gun with 6 barrels arranged around a central rotating axis, driven by a hand crank. Each barrel cycled through the sequence independently: load, fire, eject, cool, while the others were mid-cycle. With metallic cartridges, it reached 400 rounds per minute, a number that had no comparison point at the time. The design was officially declared obsolete in 1911 when single-barrel automatic weapons caught up in rate of fire. It came back in 1956 when General Electric was tasked with arming jet fighters and discovered that a single barrel couldn't sustain the rates those platforms needed without destroying itself from heat. The M61 Vulcan was the answer. 6 barrels, electric drive motor, 6,000 rounds per minute. It flies on virtually every American fighter aircraft currently in service. The M134 minigun is the rifle caliber version mounted on attack helicopters. In Predator, Blaine carries one by hand. In reality, it weighs close to 16 kilograms before you add the ammunition. Every action on this list is a different answer to the same mechanical question, and some of those answers are still being carried into combat right now. Which one do you find most interesting? Which one do you run? And which one do you think deserves more attention than it gets? Leave it in the comments. Thanks for watching. See you next time.